Hello everyone. As we have discussed that many theories were put forward to explain the nature of bonding and how chemical bond forms. Here, electronic theory of valence was proposed by Lewis and Kossel. They have tried to explain the nature of bonding individually, and together it was put forward as a theory, electronic theory. So this theory is known as what? Electronic theory of valence, because this theory is based on the valence electrons only, right? So just in the previous video we have seen that Lewis has noted the valence electrons. He observed the electronic configurations of different elements, and they have studied the electronic configuration of zero group elements, and they have noted that the peculiar electronic configuration of these zero group elements is responsible for their stability, that is the octet valence electrons, 8 valence electrons. So different scientists have studied the whole periodic table, and they have tried to understand the configurations of different elements, and they have come to the conclusion that this stable electronic configuration might be the reason for the stability. So they have observed not only that they have observed the reactivity of different group elements, main group elements, that is first A group, second A group, third A group, fourth A group, fifth A group, sixth A group, and seventh A group. They have studied the reactivity of these first to seventh A group elements, and they have come to this conclusion. What is that is, these elements, either by losing or by gaining the electrons, they try to attain this stable zero group electronic configuration, that is octet configuration. So they have proposed octet rule. Octet rule is as their common valence configuration, right? So they have observed the first A group elements, second A group elements, third A group elements, right? Let us see the first A group elements like sodium. See, this sodium will be having only one electron in the valence shell. This is a Lewis dot representation, Lewis dot structure of sodium. Okay, with one electron, one dot. One dot means one electron in the valence shell. I will write its configuration here so that you will be understand this. 1s2, 2s2, 2p6, 3s1. So this is the symbol of sodium. The inner shell electrons are shown in the form of its symbol Na, and the valence electron is shown as dot. Now what happens? This sodium, by losing that electron, it gets converted into Na plus. By losing that one electron, it is going to get converted into Na plus cation. Here in this it is going to attain 1s2, 2s2, 2p6. Now if you observe the valence shell, it is second shell. The valence shell is what? Second shell, with 2 plus 6 electrons in it. Right, 8 electrons in it, 2 plus 6. So in this way, sodium always, if you observe any chemical reaction where sodium is participating, it will be existing in the form of Na plus itself. Why? Because the one electron will be lost from sodium, and it is going to attain the octet configuration, that is zero group configuration. This is the configuration of neon. This is the configuration of what? Neon, which is very, very, very stable. So therefore in this way, sodium only prefers to lose one electron. You may be getting the doubt that why sodium is, why the formula of NaCl is, why the formula of sodium chloride is NaCl, why not it is Na2? Why? Because it is losing only one electron, and that one electron will be gained by chlorine. So if you look at the chlorines, that is 7th group, 7th A, here itself we can get clarified 7th A. If you take chlorine will be having 1, 2, 3, 4, 5, 6, 7 valence electrons. the configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So these 7 electrons are present around this. So this chlorine will be gaining this 1 electron and it is going to attain the stable configuration with the octet 1, 2, 3, 4, 5, 6, 7, 8 like this. So sodium has attained octet configuration, chlorine has attained octet configuration. So in this way, sodium loses only 1 electron, chlorine gains only 1 electron. Why not NaCl2 means chlorine requires only 1 electron, right? Okay, and why not Na2 plus means sodium requires only 1 electron. So therefore no need of 2 electrons from 2 sodium atoms. So therefore only 1 sodium atom is going to give 1 electron, 1 chlorine is going to give gain 1 electron, and they are going to form NaCl salt. So clear why NaCl formula is sodium chloride formula is NaCl? Right. Next, if you look at the second group elements like magnesium, it is shown with 2 valence electrons. The configuration of magnesium is 1s2, 2s2, 2p6, 3s2. Here it is having 2 valence electrons. Those 2 valence electrons are shown in the form of dots. Now what happens? Magnesium tries to lose those 2 electrons, minus 2 electrons. See here, 2 electrons will be lost from magnesium and it is going to attain 1s2, 2s2, 2p6. If you look at the configuration, this is the configuration of what? Neon. So it has attained stability now. By losing the 2 electrons, it has attained the stability. This is what is explained by electronic theory of valence, which was proposed by Kossel and Lewis. Both have independently proposed this. Right? On their names, this is theory. This is also known as Lewis-Kossel theory or electronic theory of valence. Now this valence of magnesium is having 8 electrons, 2s2, 2p6. So therefore magnesium is stable now, Mg2 plus. Sodium is also stable with 2s2, 2p6. So in this way, the first A group elements and second A group elements, they lose 1 and 2 electrons and they attain stability. Now if you look at the third A group element, if you take aluminium, it will be having 1, 2, 3. So aluminium loses these 3 electrons, Al plus 3, 1s2, 2s2, 2p6. Here also by using these 3 electrons, aluminium now that will be exhibiting the stable configuration, stable 0 group configuration, right? So therefore in this way aluminium will be exhibiting plus 3 oxidation state. The valency of aluminium is 3, the valency of magnesium is 2, the valency of sodium is 1. Now if you combine these elements with chlorine, if you try to combine these elements with the 7th A group element, that is chlorine, how many electrons are required by chlorine? Only 1, because that is 17th group element, and just by gaining 1 electron it is going to get converted into a 18 group electronic configuration. So therefore these halogens, they attain or they require only 1 electron. So that 1 electron they will be gaining from the electron donors like first A group, second A group, third A group elements. Okay, so here sodium by losing 1 electron, it will be forming bond with chlorine as NaCl. Now magnesium by losing 2 electrons, it is going to form bond with 2 chlorines. Right? See here, magnesium, you know that it is going to lose 2 electrons. So plus 2. Right? Magnesium is going to lose 2 electrons. It is going to form Mg2 plus 2 electrons and 2 chlorines. See, I am showing 2 here. The 2 here indicates that there are 2 chlorine atoms. 2 chlorine atoms will gain these 2 electrons. Where does these 2 electrons come from? These 2 electrons are from the electrons which are lost by magnesium. So when magnesium comes to the vicinity of chlorine, due to its affection, due to its requirements, they mutually require. Chlorine requires electron from magnesium, and magnesium prefers to lose electrons. So whenever they come closer, they undergo this process of exchanging electrons, and they will be forming this bond. So here chlorine will be forming 2Cl minus. Now this Mg plus and Cl minus, Mg plus 2 plus 2Cl minus, they are going to form MgCl2. So the formula of magnesium chloride is MgCl2, not MgCl. Is it clear why it is not MgCl or why not it is MgCl3? Because magnesium loses 2 electrons, chlorine attains 2 chlorine attains those 2 electrons, and they form bond with magnesium due to the electrostatic force of attraction. So in this way, this molecule will be exhibiting this particular ratio, 1:2 ratio, right? So the first A, second A, third A. Now let us look at the 50 A, 60 A. 60 A group elements. What are 60 A group elements? See here, oxygen, sulfur, selenium. Those are 60 A group elements. Let us take the example of oxygen. If you take the electronic configuration of oxygen, it is 1s2, 2s2, 2p4, 8. So how many electrons it requires? 2 electrons. Here oxygen valence electrons are shown like this. 1, 2, 3, 4, 5, 6. Now what does this oxygen do? It is going to gain 2 electrons and it is going to get converted into O minus 2. Right? O minus 2 with 1, 2, 3, 4, 5, 6, 7, 8. By gaining 2 electrons, oxygen is going to get converted into its stable form. That is a stable configuration will be exhibited, that is the nearest stable configuration, that is neon will be attained, right? So this is the reason why the minus will be exhibiting, oxygen will be exhibiting minus 2 charge, that is oxidation state is minus 2, the valence is minus 2. If you take 6th, 7th A group elements, 7th A group element, that is fluorine. What does this fluorine has is 1, 2, 3, 4, 5, 6, 7 electrons in its valence shell. If you look at the configuration of fluorine, it is 1s2, 2s2, 2p5 plus 1 electron. 1 electron will be required by fluorine. So by gaining that 1 electron, fluorine will be exhibiting 0 group configuration, 1, 2, 3, 4, 5, 6, 7, 8. Now fluorine is stable, right? So this is the reason why the halogens, they will be exhibiting minus 1 charge. These chalcogens, they will be exhibiting minus 2 charge, right? If you take 50 group elements, means they will be having 5 valence electrons, 1, 2, 3, 4, 5. So nitrogen, it gains 3 electrons and it is going to form N 1, 2, 3, 4, 5, 6, 7, 8. 3 valence electrons and it is going to form 8 electrons around it. That is a 0 group configuration. So in this way, these elements exhibit minus 3 charge. These elements will be exhibiting minus 1 and these elements will be exhibiting minus 2 charge. They will be showing, this first year group elements will be showing plus 1 charge, that is plus 1 oxidation state, and second year group elements plus 2, third year group elements plus 3. We will be talking about the fourth group elements later, right? So this is how the electronic theory has tried to explain the bond formation in the main group elements based on what? Electrons, valence electrons. According to this theory, elements tries to attain octet configuration either by losing or by gaining the electrons. So the first, second, third group elements by losing electrons, fifth, sixth, seventh elements by gaining the electrons, they attain the octet configuration, that is the nearest octet configuration.